Welcome to EDU World Space.
Problem 24.40. We're back at this setup for the last time, and finally we get to wonder about point P2 here. Forgot to write this in. And so what we want to do is find the potential at point P2 here. We want to find the y component of the electric field, and we want to think about why can't we find the x component from our result from the first part. And this time we have a non-uniform charge density on this. So our element of voltage from some point on the rod, and I should remark before we get any further, is that this is with the usual convention that somewhere out here at infinity the potential is zero. So this is, 1 over 4 pi epsilon naught dq over r. 1 over 4 pi. Maybe write epsilon a little more legibly. Epsilon naught. And so our dq is going to be lambda dx, cx dx, and our r is going to be the square root of x squared plus y squared. So here we have the integral of this. So we'll have c over 4 pi epsilon naught times the integral from 0 to L of x over the square root of x squared plus y squared dx. So this will give us c over 4 pi epsilon naught times the square root of L squared plus y squared minus y squared. And so if we go ahead and evaluate this for the coordinates of P2, we get 3.16 times 10 to the negative 2 volts Now the y component of the electric field is going to be the negative y derivative at that point, e dy. And so this is going to evaluate to c over 4 pi epsilon naught times 1 minus y over the square root of L squared plus y squared. And so then evaluating this with our numbers that were given, we get 0.298 volts per meter. Now, why can't we find e sub x from this? Well, the reason is that we set it up explicitly to find the potential for points on the y-axis and not for a general point anywhere in space. And so x is we integrated x out of the equation here, and so this doesn't depend on x. But it's not too difficult to realize that there has to be some x component of the field here. So this is not so helpful because this isn't the voltage at every point in space. This is not the voltage of like a general xy. This is the voltage for x equals 0 and any y. So that's why we can't find the x component using this. Because we derived this assuming at x equals 0 at the point of interest. And then we integrated over the x along here, but then we didn't include any information about the x value of the point where we want the potential.